thermal properties of matter. In the last class we have learned some of the problems based on the different scales as well as thermal expansion. Based on that we have learned 3 problems. Today let me continue the remaining problems based on those formulas. Okay, so today let us go for the 4th problem, problem number 4. A hole is drilled in a copper sheet. The diameter of the hole is 4.24 centimeter. 4.24 centimeter at 27 degrees centigrade. What is the change? What is the change in the diameter of the hole when the sheet is heated to to 27 degrees centigrade. Coefficient of linear expansion of copper is 1.70 into 10 raised to minus 5 per Kelvin. So here in this problem they have given the special. A copper sheet. Please observe, in the last class we have started problems. We have completed 3 problems I said, and already I have written the list of formulas in the previous class. So refer those formulas. Based on that we are solving today. So today we are solving the problems. I hope today it is the proper, that is lecture 9 it is. The lecture 9. In this problem they have given the sheet. Copper sheet is given, and this copper sheet is having the diameter of the hole 4.2 centimeter. Means they have made a hole in the copper sheet 4.24 centimeter at 27 degrees centigrade. Now what is the change in the diameter of the hole when the sheet is heated to 227 degrees centigrade? So what will be the one change in the diameter they are asking? the one copper sheet up to 227, naturally expansion takes place. Naturally expansion takes place means, so they are heating to that is 227 degrees centigrade. So at this temperature, what will be the diameter of this hole? You have to calculate. Means you have to calculate what is the diameter of the hole at this position, at this temperature, what will be the diameter. Means already you know whenever it is heated, expansion takes place. You have to calculate what is that new diameter. Is it clear? So for this we are using the one coefficient of linear expansion formula, that is change in length. So the length will be changed. Earlier they have given this length. Now the one length will be increased. So what will be the change in length you have to calculate. For this you have delta L is equal to L into alpha into delta T. This is only the formula it is. Very simple formula. Delta L is equal to L into alpha delta T. So here in this case, they are asking you to calculate what is the new diameter. Diameter nothing but you are taking the calculation in terms of length itself. So you can represent L itself. Okay. So what is the new change in length? Alpha. Already they have given alpha. Length is given. Temperature is given. This we have to substitute. So let me rewrite the one values by reading the question, where L is equal to 4.24 centimeter. What is the one delta alpha? Alpha is 1.70 into 10 raised to minus 5 per Kelvin. And next they have given the delta T. What is this delta T? T2 minus T1. What is T2? T2 is 227 degree centigrade minus 27. You get it is 200 degree centigrade. This is what you have for delta T. This is for delta T. You may sometimes observe, madam, sometimes you have written in Kelvin, sometimes in degree centigrade. But remember, Celsius scale and Kelvin scale. Celsius scale and Kelvin scale, both are rising by 1 degree centigrade. You say here you are expressing in 1 Kelvin. So you need not worry about Kelvin or degree centigrade. Both are equal to same. Okay. Now using that you can write the one conditions. Now let us substitute, where this is 4.24 into alpha, that is 1.70 into 10 raised to minus 5, and temperature is difference. Already you have calculated delta T, that is 200. Now by just substituting, and here this is 1.70 into 4.24, it is into 2 you have, that is 200. So you can remember, that is you can have which is of equal to, that is you can observe the value is 1.44 into 10 raised to minus 2, it is nothing but centimeter. This is the one value we have for, this is nothing but called for alpha. Change in length, that is nothing but, that is we can say delta L by L you can calculate, because remember here this where delta L, what is the new length they are asking. The new length means L2 minus L1. L2 minus L1 divided by L, if you calculate L2 by L you will have, at that time you can directly write like this, where it is, so substituting we get the one value which is of 1.44 into 10 raised to 7. So you can also write like this, where it is delta L by L is equal to alpha delta T. By directly if you write this is nothing but the fractional change in the length, where you can say the original length was 4.24 centimeter and now it has been increased to this, where you get it is equal to, that is nothing but 1.44 into 10 raised to minus 2 centimeter. This is what you can calculate for this copper sheet, which is drilled in the one copper sheet, and that has been expanded after heating. You get the new length which is of 1.44 into 10 raised to minus 2 centimeter. Okay, so this is the one, the problem based on this question. Now let me go for the next problem of the one more type using the same type of expansions. At that time I go for the one using the different diameter of the ring, and the ring are 5.243 meter and 5.231 meter respectively. At 27 degrees centigrade. To what temperature should the ring be heated? The ring be heated so as to fit the ring of the wheel. So please observe, here they have given the similar type problem. It is here the blacksmith, he fixes an iron ring. So for his bullock cart, so he fixes the one iron ring for his bullock cart. That is nothing but wooden wheel will be there. For that they are fixing at the center. So the ring, that one iron ring will be fixing to that wooden wheel, and therefore for the bullock cart. Now the diameter of the ring is given, and the ring will be there, and that they are fixing that ring on the bullock cart. They have given 2 lengths, and the temperature is given. To what temperature should the ring be heated so as to fit the rim of the wheel? So please observe, earlier it is having one length. So that length you had to select. Here you had to select which is the original length. After heating it will expand. That expansion length you only have to identify here. They did not give which is new length and also the original length. So by looking to the readings you can select which is the one original length and new length. So usually when you heat it, it will expand. So the expansion will be taken as new length, and before that we are taking, before heating it is taken as the original length. So let me write for your convenience by looking to this value, where it is first it is 5.243 meter on length, another is 5.231 meter. So among these two, this is very small value, this is slightly bigger. Compared to these two, it is slightly bigger. So you can take, this is original length L1 and this is the new length L2. Hope you understood what I said now. You are selecting the lengths in this, which is original length and which is the new length. Now you have selected the lengths. Now we have to use temperatures. Now they have said one of the temperature is given, and that temperature which is 5.231 meter respectively at 27 degrees centigrade. So here this is the one at temperature 27 degrees centigrade. So what is this? This is nothing but called as a T1. This is T1. Now what is this one new length? For this we have to calculate temperature. So let me write for your convenience. This is capital T1 and this is T2. This is we do not know what is it. We have to calculate what is this new temperature. After heating you get original length, and that you have to now calculate this. Okay. Now in this problem they did not give the one coefficient of linear expansion. Here they did not give coefficient of linear expansion, but for the one ring, which type of ring it is, which is made up of the ring, iron ring they have said. So you have to take coefficient of expansion for the iron it is. Okay. So for your reference I give the value. What is it? It is alpha, where for iron, alpha for iron is 1 raised to minus 5 per Kelvin. So this is the one. If you remember, okay, no problem. Usually they will give the one value, but in this problem nowhere they have given, so we let us take by using the one table, right? Now let me write the one formula for this. You have to calculate temperature. First let me write the formula for this case, where L2 is equal to L1 into 1 plus alpha into delta T. This is our original formula, right? But you know what is delta T? Delta T is what? T2 minus T1. This is T2 minus T1. So let me write this one here. L2 is equal to L1 into 1 plus alpha T2 minus T1. Hope you understood what I have written here. This is the one formula. Now we have written. Already we know L1, L2, alpha we know, T1 is known, T2 you have to calculate. So first let me write the values. So what shall I write now? Let me write these values now. By using this, let me write L2 value 5.243, which is equal to 5.231 into 1 plus alpha. Alpha is 1.20 into 10 raised to minus 5, and this is T2. T2 which is you do not know, T2 minus T1. T1 is 27 degree centigrade. Okay, this is the one values I have substituted. Just I have substituted. Okay, now by just equating these values, finally you get. Here remember, this denominator I take here, and this you equate, and finally we have to open the bracket T2 minus T1, and we have to get finally T2 by simpler mathematical equation. T2 is equal to, it is 218 degree centigrade. You get 218 degree centigrade. So just open the first, you multiply this by alpha into T2 minus alpha into T1. This we write, and finally we remove this one, we keep it here, we equate for T2, we get this. Okay. Even after completing this, you can also verify by just substituting. By, for example, if you substitute 218 here by T2 minus T1 and just multiplying and equating this, you get this value. Finally you get this, where LHS is equal to RHS. You can confirm your answer also after getting that readings. So just by simple mathematics you can calculate this. So this is one more time. Here iron ring they have here, where you are using the same formula, coefficient of linear expansion. Okay, right. Now let me go for the remaining one more time problem in this. Next problem number 6. Okay, next type problem which is of this type, which was given in this board exam, this one problem, where the question paper, where you know as per the NCERT syllabus they have given model papers. The model paper problem it is, I'll show you what it is. A copper plate. It is a model paper problem it is. This is model paper problem. A copper plate has an area of 250 centimeters square at 0 degree centigrade. Calculate the area of the plate. The area of the plate at 60 degree centigrade. Given coefficient of linear expansion of copper. Linear expansion of copper, which is 1.7 into 10 raised to minus 5 per degree centigrade. Okay, this is the one question they have given. Please observe, in this problem they have given copper plate. So this is the one plate you have, which is made up of copper. In this, the one area is given, which is of 250 centimeter square at 0 degree centigrade. Calculate the area of the plate at 60 degree centigrade, given coefficient of linear expansion of copper they are given. So they have given in this problem to calculate the new area at this temperature. Right? So the one at this temperature, what will be there? You know already, when you heat this, expansion takes place. So the new expansion will be the one, whatever the area you have to calculate. But in this slightly they have been the change. They have set to calculate area, but they have been coefficient of linear expansion. So you have to calculate beta using alpha. I think you are following what I say. They have given alpha here. So using alpha you have to calculate beta, coefficient of superficial expansion. That is nothing but the one beta. Right? So let me tell you how to calculate this problem. Now in this, please observe, they are asking to calculate what is the one new area. Right? So first let me write the values, whatever is given here. So let me write the one value given by this. The new area, initial area is, let me write it for your reference. This is A1. A1 is 250 centimeter square at 0 degree centigrade. Right? Now what is A2? A2 you have to calculate at 60 degree centigrade. I think you are following what I said. The new area you have to calculate here. Okay. Now next, coefficient of linear expansion is given, which is 1.7 into 10 raised to minus 5 per degree centigrade. So this is what they have given. Now using this, first let me write the formula. Right. For the area, you already know, according to coefficient of superficial expansion, A2 is equal to A1 into 1 plus beta into delta T. I think 1 plus beta into delta T. Right? So this is what we have. Now, first let me write here. You are calculating the one. First delta T you have to calculate first. Area A1, A2 you have to calculate second step. Beta, first let us write what is beta and then let us substitute here. First let me write, that is A1 we already know. Beta. Beta, to calculate beta, we know beta is equal to 2 times of alpha. So let me write 2 into 1.7 into 10 raised to minus 5. This is for beta. Okay, right. What is delta T? Where delta T is equal to T2 minus T1. What is T2? 60 minus 0 degree. So you get it is 60 degree centigrade. So 60 minus 0. Right? You get 60 degree centigrade. This is delta T. And 2 into 1.7 means it is 17 to 34. It is nothing but 3.4 into 10 raised to minus 5 per, that is in terms of degree centigrade per degree centigrade. So this is how we are calculating. This is for beta. Now you got the answer for beta, delta T. Now let us substitute here. So if you substitute here in this, where it is 17, that is right. 17 to 34. Okay, alright. So please write now, let us write now. It is A2 equal to A1 250 into 1 plus, it is 3.4 into 10 raised to minus 5 into delta T. Delta T is how much? 60 degrees centigrade. Okay. Now this 1 plus this much you have. So 3.4 into 60 first we have to calculate, and then we have to add this one. Then we will get the one bracket value. And then after that you have to multiply this. Hope you are understanding what I say. It is 3.4 into the 60 first you have to multiply. Plus 1 you have to add this. And that will be multiplied by 250. So after calculating, finally you get it is nothing but it is 250.51. It is centimeter square. A small change it is. Right? So earlier it was only 250. Now it is 250.51 centimeter square, which is the new area after expansion when it is heated up to 60 degrees centigrade. Hope you understood this problem. So please observe. In this the first part you have to observe. They have given the one copper plate area. Original area is given. You have to calculate new area. And original area at what temperature they have given. You have to calculate the one new area at 60 degree. They have given already temperature. So at 60 degree what is the new area you have calculated. This you have to remember. Now temperature difference you are calculating by using this formula. Okay, and in this problem they have given coefficient of expansion, that is linear coefficient they have given. Now for this area we are using beta, but we know as per the concept alpha is to beta is to gamma is 1 is to 2 is to 3 ratio. So using that ratio, now we know beta is 2 times of alpha. Already we know alpha, so we get beta. Substituting we get this. Hope you understood. This is very simple, but stages you have to remember what to be calculated here. So read the question carefully. You can do it very comfortably. So this was once in the model paper they have given this. So the one NCERT pattern of question paper. Okay. Right. One more time now. Let me calculate for this one. We have, as per the NCERT problem, we have this one. A steel tape. Let me go for the next problem. Problem number 7. Problem number is 7. A steel tape 1 meter long is correctly calibrated for a temperature of 27 degrees centigrade. The length of the steel rod, the length of the steel rod is measured by this tape, is found to be 63 centimeter on a hot day. Hot day. When the temperature is 45 degrees centigrade. What is the actual length? What is the actual length of the steel rod on a day when the temperature is 27 degrees centigrade. Temperature is 27 degrees centigrade. Coefficient of linear expansion. Coefficient of linear expansion of steel is 1.20 into 10 raised to minus 5, that is per Kelvin. Okay, this is the one question they have given. Please observe. They have given in this problem, it is an NCERT problem, it is a steel tape. The tape is of 1 meter long, which was correctly calculated for a temperature of 27 degrees centigrade. 1 meter means 100 centimeter long it is. The length of the steel rod is measured by this tape is found to be 63 centimeter on a hot day. So it was measured, it is 63 centimeter it is. It is given 63 centimeter on a hot day. Right, 63 centimeter which was on hot day. Now using this, they have said hot day means nothing but summer. During summer temperature will be more, so temperature was 27 degrees centigrade. And what is the actual length of the rod on a day when the temperature is 27 degrees centigrade? So earlier temperature was 27 degrees centigrade. At that temperature the tape was 1 meter long. Now they are measuring this length of the steel rod. That steel rod is measured on this tape. At the tape we have already 1 meter long tape. In that they are measuring this rod. For example, if you have this is 1 meter long tape it is. If you say this is the 1 meter long tape. In this we have a rod, and that rod, let me say this is of one rod which is measured, which is of 63 centimeter. When it is measured on the day which is having temperature 45 degrees centigrade. So they have measured this. What is the actual length of the rod when the temperature is 27 degrees centigrade? They are asking what is the actual length they are asking to calculate. So first let us calculate what is the change in length. After calculating change in length and then using the one original length, now let us calculate what is the length of the rod. Okay. Now first let me calculate what was the difference in temperature. First let us calculate what is delta T. Delta T means you know already T2 minus T1. So we have T2 minus T1 that is 27 degree centigrade. So 15 minus 7 is 8. Here it is 1. So 18 degree centigrade. So this is the one rise in temperature. That is delta T. You already have calculated delta T. Now let us calculate what is the change in length. So the change in length means delta L is equal to L alpha delta T. So the change in length let us calculate. So L alpha delta T. So you know what is this 1 alpha delta T here, that is L. L is 63 centimeter they have given. Alpha is given. Delta T is given. So first let me take what is L, 63 centimeter. Because you know already L is equal to 63 centimeter they have given there. Right? Now into alpha. What is alpha? This is the one coefficient of linear expansion. 1.20 into 10 raised to minus 5. What is a change in temperature? It is 18 degree centigrade. So that is nothing but or. You can also write 18 Kelvin. Okay, both are the one and the same because here Kelvin per Kelvin you have, that will get cancelled. It is 18. Okay, so by just first let us calculate what is a delta L, nothing but change in length. Suppose if you just multiply, you get the value. It is of 0.0136 centimeter. So this is the one change in length, and you can observe when there was a difference in temperature. Now what is the actual length of the rod on the day when the temperature is 27 degrees centigrade? Now we have to calculate what is the actual length. That actual length of the rod at this temperature. That is, first let us calculate the one. For today we got this 45 degrees centigrade. The temperature we have calculated, and this for this temperature we have calculated the one length. Now first let us calculate what is the length at 45 degree centigrade. Okay, so what will be the actual length at 45 degree centigrade? So let us calculate actual length of the rod, actual length of the rod at 45 degree centigrade, because we have calculated difference in temperature, so we have to take this at 45 degree centigrade. So this will be, earlier it was 63 centimeter, now there was an increase in the length, that you have to calculate, that is L plus delta L, that is L plus delta L. L is 63 centimeter and this is 0.0136. So you get which is 63.0136 centimeters. So you know the one, what is the actual length at this position. So the day when the temperature was given. So please observe. You better remember. So this is the actual length at 45 degrees centigrade we have to write. This will be correct. Then on the question will be correct. This is 45 degrees centigrade. So this is the one answer. So please observe. First step, steel tape is given at 27 degrees centigrade, which is 1 meter long steel tape. I said this is the one steel tape you have. Right. Now the length of the steel rod is measured. We have a rod which is made up of steel. That rod is measured on this, and it was found to be how much? 63 centimeter on a hot day. They have measured this, that is on hot day what is the temperature. At 45 degrees centigrade, what was the one length means 63 centimeter. Now what is the length of actual length of the rod on the day when the temperature is 45 degrees centigrade? Actual length they are asking. So please observe. This is for actual length. For 45 degrees is correct because 27 degrees centigrade the steel tape was given and they have measured this on 63 centimeter. Means as the temperature increases, naturally the one length increases. So this is the one we have rise in temperature. Using this we have calculated this. Now L plus delta L means it is the one. The expansion has been taken place on that the one steel rod. So that will be calculated here. So the actual length of the rod at 45 degrees centigrade is 63.0136 centimeters. This is what you have to calculate for this one. Okay, this is the one question. Right. Now let me go for the another type problem. Next problem, problem number 8. Problem number 8. A brass wire 1.8 meter long at 27 degrees centigrade is held taut with a little tension between two rigid supports. If the wire is cooled to a temperature, if the wire is cooled to a temperature of -39 degrees centigrade, what is the tension developed in the wire? If its diameter is 2 millimeter. 2 millimeter. Coefficient of linear expansion of brass is 2 into 10 raised to -5 per degree centigrade. Young's modulus of brass. Young's modulus of brass is 0.91 into 10 raised to 11 Pascal. So please observe, they have given the question here. Brass wire 1.8 meter long it is at 27 degrees centigrade and it is held taut with little tension between two rigid supports. So we have two rigid supports here. If this is the two rigid support, here we are connecting the is the brass wire which is of 1.8 meter long. Right? At what temperature? At 27 degrees centigrade. Now, if the wire is cooled to a temperature of minus 39 degrees centigrade, means they are cooling this temperature. So, when you cool this, what is the tension developed in the wire? If it is, the diameter is 2 mm. So, diameter is 2 millimeter. So, what will be the one tension developed in the wire they are asking. So, please observe, maybe heating or cooling. When you heat, expansion takes place. When you cool, contraction takes place. Here they are cooling to minus 39 degrees centigrade. So, contraction takes place. So, what will be the contraction? When the contraction takes place, what will be the tension developed in the wire? So, what will be the tension developed in the wire? You have to calculate. But they are saying here, what is the tension developed in the wire in this? You have to calculate. When the temperature has been decreased to minus 39 degrees centigrade. So, first let us calculate. So, tension is nothing but force. You have to calculate force. So, it is none other than the problem based on thermal stress. So, here thermal means it is due to a heating here. But here cooling also you can explain the one heating and one due to expansion, cooling due to contraction can be taken place for the one wire when it is connected to two rigid supports. So, that you have to calculate now. So, let us calculate first the force. How to calculate force? Before going to that, first let us write the formula for thermal stress. Thermal stress means it is nothing but force per unit area. Already you know regarding the force per unit area using Young's modulus of elasticity, we have the formula like this. According to Young's modulus, Y is equal to F by A. That is A into divided by delta L by L. So, this is due to longitudinal stress, it is due to longitudinal strain. But here we are explaining with respect to thermal stress. This is due to thermal stress, this is due to thermal strain. Okay. Now, if you rewrite this formula, you get F by A into, this is L by delta L. This becomes L by delta L. Right? Like this. Okay, but remember area, they did not say directly area, they have given diameter, so they are asking about diameter. You know that wire is just looking like a circle, so you have to write first calculate area of the circle. You know A is equal to pi r square, pi r square, A is equal to pi r square for this one which is of wire, right? This, let me say this is the wire, this wire is out this side, it is looking like a circle, so you are using the formula for area of the circle. Here pi r square, r means radius, but in this question they have given diameter. Let me convert this to diameter. So you know d is equal to 2r. So d is equal to 2r, where r is equal to d by 2. This is the one formula we have. So first let me write this is of pi d square by 4 it is. Because pi d by 2 whole square means you get pi d square by 4. This is the one area you have to use now. This is the formula we are using. Wherever you have formula A. Okay. Now your original formula becomes y is equal to f divided by pi d square by 4 into L by delta L. Okay. This 4 will go to numerator. So y is equal to 4fL divided by pi d square into delta L. Hope you understood how I have written this formula and taken that 4 to the numerator. You get it is 4fL divided by pi d square into delta L. Right? Now, we have to substitute the values now. What are the given things? Let me write first what is given here. Using that, let us write the one conditions for it. So, before going to this here, force. First to calculate force, you know only Young's modulus here. This Young's modulus is known, coefficient of this is nothing but first let us calculate the one, the delta L, original length, that is nothing but change in length, let us calculate. Using that, let us write the formula. So, it is nothing but L. L is of 1.8 meter, which is 1.8 meter. How to calculate this delta L? Delta L, L into alpha into delta T. So to calculate L into alpha into delta T. What is this L? L is 1.8 meter. What is alpha? Alpha, which is known as 2 into 10 raised to minus 5. What is delta T? Delta T is the temperature, which is earlier this is the original temperature is 27 and the new temperature is minus 39. So let us write this is that 27 degree centigrade minus of minus 39 degree centigrade. This is our formula. T delta T minus, that is T2 minus T1. Okay. Now using this you get this itself, where delta T this itself will become 66 degree, minus into minus plus. So that will be plus into this one will become nothing but it is 39 and minus into minus means plus 39 plus 27. You get 66 it is, right? So it is 1.8 2 into 10 raised to minus 5 into 66. So what is delta L you get? Delta L is 2.376 into 10 raised to minus 5. This is delta L, centimeter. We got delta L, right? So okay, we got delta L and we know diameter. What is the diameter they have given? Diameter is of 2 millimeter. So what is diameter 2 millimeter means? It is D is equal to, let us write what is D. D is equal to 2 millimeter. 2 into 10 raised to minus 3 meter it is diameter. This we have to substitute for D. Okay, where it is pi? Pi is 3.14. You can substitute pi as 3.14. Already we know delta L. We know original length it is L. That is 1.8. You have to calculate that is F. So first let me wait for the formula for F. So I just rewrite this formula for F like this. How to write this one? F is equal to Y into pi d square into delta L divided by 4L. Hope you understood with this. This is, remember, F it is 4FL, 4FL, right? Y into pi into d square into delta L. So this is the one formula we have. After substituting, let us write F is equal to Y is how much? 0.91 into 10 raised to 11 Pascal into 3.14 into D. D you have already know it is 2 into 10 raised to minus 3 whole square delta L. Just now you got delta L. It is 2.376. First I write here because it's a very big number. I write slightly here itself. F is equal to that is 0.91 into 10 raised to 11 3.14. D is 2 into 10 raised to minus 3 whole square delta L is 2.376 into 10 raised to minus 5 divided by 4 into 1.8. So you get, after completing multiplying and putting the 1 squares everything, finally you get the answer. It is 3.8 into 10 raised to 2 Newton. So please observe this problem based on thermal stress it is. Here they have given brass wire, original length of the brass wire at 27 degrees centigrade, and this has been held tight with a little tension exerted at the rigid supports, between the two rigid supports. Now they are pulling this by minus 39 degrees centigrade, and when when the tension is developed here, what will be the tension developed here? Naturally, tension will be developed at the one wire, and that tension you have to calculate. Tension is nothing but force. That force you have to calculate here. But remember, wire is given. Since there is an expansion along its length, so they have given linear coefficient of expansion of that one wire made up of brass. That coefficient of expansion you are taking here. So at the same time, they are explaining the one diameter. It has been extending with respect to diameter they have given. So you already know, as per the one expansion, that is the one modulus of elasticity along its length, you know Young's modulus, this formula. We are rewriting this formula like this. Okay, this is the one thermal stress by thermal strain or longitudinal stress by longitudinal strain. Okay, now I am rewriting this. Since we know area, wire is looking like a circle, so we have to take the consideration formula pi r square. Since they have given the question in diameter, I am converting this to diameter because you know d is equal to r is equal to d by 2, and substituting all these values we get the answer here. Before substituting, first we have to calculate this delta L, and substituting these values you get F equal to this much, which is 3.8 to 10 raised to 2 Newton. So it's a 5-mark problem it is. Hope you understood this. Be careful going through all the things. Okay, we have completed nearly 8 problems.